Welcome back to the fourth day of 12 integrals, and today I'm going to be showing you a very cool integration trick that you can do at home. Now, it could be worked out that the integral of 1 over x squared plus a squared from 0 to infinity would just be pi over 2a, where a is just a constant. But what's a lot more interesting is this integral. I want you to find this integral, given that you know the answer to the previous integral I have shown you. What is the integral of 1 over x squared plus a squared squared from 0 to infinity? So have a think about it for a bit. You think you have an answer? Let's take a look at the answer. Now in this video, I'm going to be showing you something called Leibniz rule, or as some people would call it, the Feynman trick. And what it basically says is it says that if you have a derivative in front of the integral, you can take that derivative inside. Now you could actually prove that Leibniz rule actually works. The picture of the proof is here, as you can see on the screen right now, and if you want to see the proof, I'll leave a link of it somewhere on the screen so you can click and go watch it. But if you're not that interested in the proof, then just watch on. So now that we've established Leibniz rule, where we can just take the derivative inside the integral, let's try to see how it would help us solving the equation that we had earlier.
I'll remind you that what we're trying to find is the following integral. We're trying to evaluate the integral of dx divided by x squared plus a squared to the power of 2. This is what we're trying to work out. So I'll put a little cloud-shaped thing around it like that. So what I could do is I could differentiate both sides with respect to a. So what I can do is I could differentiate both sides with respect to a like this. So eventually now we have the following equals to, and then we also have to differentiate this side with respect to a. And so we have that. Now, what I can do is I could take this derivative inside the function as I've set up here. So what we end up with is we end up with the integral of the derivative of this function plus a squared with respect to x equals to the derivative of pi over 2a with respect to a. And so now what we have to do is we have to evaluate these two integrals, which could be a bit of a pain to do. So we'll evaluate the left-hand side first. We have to work out this derivative. And in order to work out this derivative, I'll do it on this side here. We'll have to use the chain rule. Now, 1 over something is like that thing to the power of minus 1. So I'll just rewrite it as that. So we have here, we have dA of dA times x squared plus a squared to the power of minus 1, right? And so what we do here is we just do a bit of shape. So first we have to move the power to the front. So just be like this, a squared to the power of minus 2. Then we differentiate inside with respect to a as well. And that would just come out as 2a. Easy. Now, the next bit we have to differentiate is this expression here. And in order to differentiate this expression, you can first rewrite it as like as an exponent. So d of dA, I'm just going to rewrite it here. This would just be the same as pi over 2 multiplied by a to the minus 1, right? And this would just equal to, if you use like that basic differentiation rule, that would just be to minus pi over 2 multiplied by a to the power of minus 2. So now I can rewrite this whole bit over here according to this result that we have. So this expression here would become the, I'm going to move here because that's why. So this would become 0 from 0 to infinity, the integral, and this bit would be rewritten as that. So this would just be minus 2a divided by x squared plus a squared with respect to x. As you can see, this is power of minus 2, so I made it divided by that to the power of 2. This equals to this. So there'll be minus pi over 2a squared. That's just algebraic bit to make it look a bit simpler. So now you can see that this integral looks really similar to that integral, but all we have to do now is just divide both sides by minus 2a. Because basically here, because we're integrating with respect to x, you can just treat a in here as a constant. I know we differentiated with respect to a earlier, but now its a is no longer a variable anymore. We can treat it as a constant. And so what we get here, I'm just going to skip right to the answer. You could check the algebra in a second if you want. We'll just get that the integral from 0 to infinity of dx divided by x squared plus a squared to the power of 2 equals to pi over 2a squared multiplied by 1 over 2a. And obviously, because the minus here cancels each other out, and you would just get the answer of pi divided by 4a cubed. And that is the answer of your integral.
And that is how you can make your life a lot easier when you're integrating. Thank you very much, and I'll see you again in tomorrow's episode.